Hello everyone. CrowdStrike's fastest observed breakthrough time is 7 minutes. Horizon 3 autonomous agent goes from the initial access to full privilege escalation in 60 seconds. Meanwhile, a human incident responder at 3 am is still looking up the command line flags. That gap is the most dangerous problem in the cybersecurity. I built ThreatePipe version 2 to close it. It is an autonomous Swift native incident response agent that doesn't just suggest the commands, it is actually execute the forensic workflow safety at machine speed without hallucinating or destroying evidence. You can see here the which are the test cases, and I generated that logs which are a total lines of 298 73 attack lines and 225 it is a normal log file which are generated, and I run the streamlit dashboard which are I show firstly, and this generated logs generate test logs .py file here are generated. See here realistic attack log file. You can run this tool via CLI also as per mention on the GitHub readme file, but now for the demo I will show on the Streamlit app. I Here you can see first 20 logs, and here control you can add your Mistral API key via Streamlit app also. You can control settings, and here a hacker mindset.db it is created. So let's start the analysis. Here are the two boxes where you can see the live results which are LLM generated. Here you can see suspicious log detected, here .env file which are a .env file to get accesses, verdict malicious, confidence 90%, stage recon and cycle. At the one cycle here verdicted the file is malicious. So we will wait some 5 minutes to complete this analysis. The LLM determined the result was ambiguous, confidence was too low. The self-correction loop kicks in, it increments the cycle and automatically selects the alternate tool to get better evidence. This mimics exactly how the senior analyst pivots their investigation. So finally our analysis are completed. Here are result: 50 logs investigated, malicious are 16, suspicious are 8, and it is cost give to the LLM. So let's switch on our result tab. This is a detailed log analysis which are 50 and graph. You can see here as per hackathon mentioned each step, and their result will be stored on the database. Here are the detailed IP artifact factor sensitive file props. Here are clearly explanation and cycle, and here you can see the reinvestigate up to cycle 3. Here this log is a binning, so I will show you the malicious logs, and here clearly give the reason, and this agent work on the complex vulnerabilities also. I will show that vulnerabilities. Yes, this is a JSP CMD JSP file. Here I correctly detected that file and done analysis. Artifact type unknown. Here also Python file detected correctly. And finally here are a mindset graph. Pipeline generates a mindset alert report. It is correctly identify the campaign mapped on primary IP to the exfil stage, and they give to the SOC team actionable MITRE techniques and immediate block actions. So you can see here which IPs are need to block, how they are worked. Here are attacker transition graph, and here clearly explanation that how attacker thinks and what is next movement of that attacker. So you can read here complete report. And this hacker mindset graph, it is a persistent across the session. You can see the attacker's propagation from the recon to scan all backdoors and the transition they look. And crucially, the evidence graph provides complete chain of custody. Here you can see the evidence graph. Every verdict can be traced back to the exact shift tool execution and produced it zero hallucinated claims. And now I will show you my MCP tool. Here are see you can block the patterns and allowed shift tools. To the wrap up, I want to show why this is safe for production. In our MCP tool layer, we define an allow list, only read only forensics tools are here. If the LLM ever hallucinated and command like rm.rf, the MCP server blocks it architecturally, zero evidence, spoiled risk. The ThreatePipe proves that we can close the speed gap by combining LangGraph self-correction and MCP architectural gradles. We can build AI agent that find evil at machine speed safely. And I will show you now my GitHub readme file. Here you can see detailed. Here my project is uniqueness are persistent attacker tracking maps. Attacker behave the persistent hacker mindset graph, calculating risk score and predicting the next MITR attack moves. Here my architecture, some features, system requirement, installation steps, and you can test the MCP tool via CLI also. Here my accuracy and dataset report. Okay, I will show you now accuracy report. You can read here my accuracy report also. There are clearly mentioned how my agent are zero hallucinated. Similar as a dataset report also. This is my file project structure. So thank you.